a world where drought meant death and disease ravaged settlements, one civilization dared to defy nature's limits. Imagine the parched earth, the desperate cries for sustenance, the constant threat of illness lurking in stagnant pools. Against this backdrop, a monumental achievement emerged, a testament to human ingenuity and an unyielding will to thrive. This is the story of how Rome, a city destined to house 1 million souls, harnessed the very essence of life, water. From humble beginnings on the Tiber's banks, Rome grew into an empire, and its survival, its very identity, became inextricably linked to the steady, clean flow delivered by its aqueducts. These weren't mere channels, they were the arteries of an empire, pumping vitality into every corner of its vast dominion. The significance of these engineering marvels extended far beyond simple hydration. A reliable water supply was the bedrock of Roman power, the silent engine driving its political stability, military might, and economic prosperity. Without it, the vast urban centers that defined Roman civilization could not have existed. These structures sustained staggering populations, enabling unprecedented urban development and cementing the centralized control that Rome wielded over its territories. Water became a tool of public order and health. The grand public baths, sparkling fountains, and sophisticated sanitation systems were not just amenities, but symbols of Roman dominance and a means to maintain social cohesion. Imagine the sheer logistical nightmare of supplying a city the size of ancient Rome without such a system. Disease would have run rampant, social unrest would have festered, and the very foundation of the empire would have crumbled. Beyond the city walls, aqueducts allowed Roman legions to establish permanent garrisons in even the most arid regions, projecting power and supporting the growth of new cities across the empire. Economically, this abundance of water supported flourishing industries, irrigated vast agricultural lands, and fueled a thriving economy. From the fullers who processed wool to the millers grinding grain, water was the indispensable resource. It touched every aspect of daily Roman life, from the simple act of drawing fresh water for cooking to the elaborate rituals of public hygiene and even the spectacular, water-filled gladiatorial games known as naumachii. The aqueducts transformed a once desperate struggle for water into a symbol of unparalleled luxury and control. But before a single stone was laid, before the roar of 1 million gallons cascaded into the city, there was meticulous planning. The blueprint for hydration began with an exhaustive survey. Roman engineers scoured the landscape, identifying pristine water sources like mountain springs and clean rivers, meticulously assessing their quality and calculating potential flow rates. This wasn't guesswork. It was a science. The legendary Roman surveyors, known as grammatici, were masters of their craft. Armed with ingenious tools like the corrobits, a sophisticated leveling instrument, the dioptra for sighting, and the groma for establishing precise right angles, they navigated rugged terrain with astonishing accuracy. The Roman obsession with precision was paramount, even in these initial stages. They understood that the success of an aqueduct hinged entirely on maintaining a continuous downhill flow without excessive velocity, which could erode the channels. This required an almost imperceptible gradient, a delicate balance of elevation that ensured water moved steadily by gravity alone. Every contour of the land was mapped, every potential obstacle considered. It was a Herculean undertaking of observation and calculation, an intellectual feat that preceded the physical marvels. To understand the sheer ambition behind these structures and explore more wonders of the ancient world, consider subscribing to our channel. The ambition forged in those initial surveys soon transitioned into an even grander undertaking: the physical construction. Bringing these blueprints to life was a monumental task, demanding immense labor and a masterful understanding of materials. The process began at the source, where engineers designed intricate systems to capture the water. This involved building small dams to divert springs or rivers, creating collecting basins, and often incorporating initial filtration layers of sand and gravel to remove larger impurities before the water even began its journey. From these sources, the water flowed into channels. Where mountains stood in the way, the Romans didn't go around, they went through. Tunneling was an arduous and perilous endeavor. Teams of quarrymen, often working from both ends of a mountain, would excavate underground channels using pickaxes and chisels. For particularly hard rock, they employed a technique called fire setting, heating the rock with fire, then dousing it with cold water to crack it, making it easier to break apart. The lack of ventilation and the constant threat of collapse made this work incredibly dangerous, a stark reminder of the human cost behind these marvels. Across plains and gentle slopes, open channels were trenched, often lined with a remarkably durable and waterproof mortar known as opus signinum. This reddish-pink plaster, made from lime, sand, and crushed terracotta, was essential for preventing leaks and preserving water quality. But perhaps the most iconic and visually stunning aspect of Roman aqueducts was their solution for bridging valleys: the majestic arcaded structures. These multi-tiered bridges, often soaring hundreds of feet above the landscape, were a testament to Roman architectural prowess and their mastery of the arch. Each stone, precisely cut and expertly placed, contributed to a structure designed to stand for centuries. The materials themselves were chosen for their strength and longevity. Local quarries provided vast quantities of stone, limestone, tufa, and travertine, which had to be transported sometimes over long distances using rudimentary but effective methods involving oxen and sledges. Then there was the revolutionary Roman concrete, opus cementitium. This wasn't just any concrete. It was a miraculous blend of volcanic ash, known as pozzolana, mixed with lime and aggregate. Pozzolana gave the concrete its incredible strength and, crucially, its ability to set underwater and resist moisture, making it ideal for foundations and waterproof linings. For distributing water within the city, lead pipes, or fistulae, were manufactured by bending and soldering lead sheets. While effective, the long-term health implications of lead in drinking water would only be understood much later. The sheer scale of manpower required was staggering. Engineers planned, surveyors plotted, but it was the multitude of quarrymen, masons, carpenters, and countless laborers, including a significant number of slaves, who physically built these conduits. Each had a specialized role, working together in a highly organized, almost industrial fashion. Yet, this Herculean task was fraught with hidden risks. Aqueduct construction was inherently dangerous and immensely costly. Tunnel collapses were a constant threat, burying workers alive. The harsh conditions in work camps, coupled with exposure to the elements, led to rampant disease. Miscalculations in the design of arches or foundations could lead to catastrophic structural failures, requiring costly rebuilds. Even after completion, aqueducts demanded constant vigilance and maintenance against leaks, blockages, and even enemy sabotage during times of conflict. The financial investment was astronomical, and the human lives sacrificed to bring water to Rome were countless. Balancing cost, speed, and structural integrity was an eternal engineering dilemma. However, Roman ingenuity often found solutions to these seemingly impossible challenges. To cross deep valleys where building towering arcades was impractical or too expensive, they employed inverted siphons. This involved using robust lead or stone pipes that descended into the valley, harnessing pressure to force the water up the other side. It was a sophisticated application of hydraulic principles, demonstrating an advanced understanding of fluid dynamics. For long tunnels, ventilation shafts, or puteoli, were dug at regular intervals, providing fresh air for workers and later allowing maintenance crews access for inspections and repairs. Sedimentation tanks, known as piscinae limariae, were strategically placed along the channel. These wide, shallow basins slowed the water's flow, allowing sand and other impurities to settle out before the water continued its journey, improving its quality. While many civilizations built impressive structures, Rome's unique contribution lay in its systematic approach, scaling these complex engineering solutions across an entire empire, creating an unparalleled network of vital infrastructure. Once the life-giving water arrived at the city's edge, its journey wasn't over. It flowed into the Castellum Divisorium, a monumental distribution tank, often elevated to maintain pressure. From this central hub, the water was meticulously channeled through a sophisticated three-tier system designed to serve Rome's vast population and myriad public functions. First and foremost, public fountains provided guaranteed access to clean water for all citizens, a fundamental right in Roman society. Next, the immense public baths and latrines, cornerstones of Roman hygiene and social life, consumed vast quantities of water, transforming daily rituals into communal experiences. Finally, for the wealthiest citizens and certain industries, private connections, known as aqueducts, were available, though these required a special permit and often a hefty fee. Managing this intricate network was a constant challenge. Dedicated water administrators, the curatores aquarum, oversaw the system, while specialized crews, the aquarii, were responsible for its maintenance. Their daily battle involved preventing illegal tapping, clearing blockages from sediment, and repairing leaks that could compromise the entire supply. The sheer volume of water diverted had a significant, though often unseen, environmental impact, altering local ecosystems and water tables outside the city. Rome's ability to construct and maintain such an extensive system wasn't just about engineering prowess. It was rooted in unparalleled organization and logistics. The Romans excelled at mobilizing vast resources, coordinating complex projects across immense distances, and sustaining these efforts over centuries. Their superior organizational structure, standardized engineering practices, and unwavering political will distinguished them. While earlier civilizations built impressive local irrigation systems, none matched Rome's empire-wide scale and systematic approach to urban water supply. The aqueducts were not merely aesthetic wonders, they were functional marvels, prioritizing utility above all else. They embodied the Roman genius for practical application, transforming raw engineering into a vital public service. With the decline of the Western Roman Empire, the fate of these magnificent aqueducts varied. Many suffered neglect, their channels crumbling, their arches collapsing as maintenance ceased. Some were deliberately destroyed by invaders, cutting off the lifeblood of besieged cities, yet others proved resilient, repurposed by medieval societies for mills or smaller-scale irrigation. The knowledge embedded within their construction was not entirely lost. Renaissance engineers, studying Roman texts and ruins, rediscovered principles that would influence hydraulic engineering for centuries. The fundamental concepts of gravity-fed water systems, sedimentation, and pressure dynamics that the Romans mastered still underpin modern water infrastructure. Every pipe and tap in our contemporary cities carries a silent echo of their ambition. The Roman aqueducts stand not just as ruins, but as enduring testaments to human ingenuity, ambition, and the relentless pursuit of progress. They remind us that even the most basic necessity, water, can be transformed into a symbol of power, order, and civilization itself. Their legacy flows through every pipe and tap in our modern cities, a silent echo of the Roman dream. Dive deeper into the foundations of our world by exploring other ancient civilizations and their remarkable achievements.